Hello and welcome to 5-Minute Math. Today we are looking at day 10 of a 12-day review of the entire 4th grade math curriculum. As always, we are using the 2017 Release Star Test from the state of Texas. Today we're looking at protractors, we're looking at angles, and also relative weight and mass. So this item that you see on the screen looks kind of like a half moon or a semicircle. This is called a protractor, and it's a measurement tool. You see the numbers, so think of it like a ruler, but of angles, because angles are the space between two lines. So we have all of these angles right here, and these all happen to be small, acute angles. But we're trying to find which of these does not, thankfully they capitalize that, have a measure of 23 degrees. So how do we read the protractors? Because as you notice, we've got two sets of numbers. We've got numbers going from 0 to 180 on the outside, but then on the inside, it goes from 0 to 180. So that could be kind of confusing. The reason is you always want to put your vertex. Let me put your vertex. Your vertex always needs to go, that's where the two lines meet, or the two rays meet, has to be in the exact center. So sometimes the angle opens off to the right, like it does in F. Sometimes it opens up more to the left, like it does in G or J. And so that's going to change the numbers. And so if you are looking to the right, you always put this bottom one right here. If you can, always try to put that on 0. Sometimes you can't. And so then we're going to read the inside numbers, because here's our 0, and it's going to open. So we're just going to imagine that this angle is opening here. And it looks like this has got 0, 10, 20. Yeah, that looks about 23, because here's my about 23 right there. So I'm going to say this looks like 23, which means it's not going to be the answer, because we're finding the one that does not have 23 degrees. Let's look at G. So G is a little bit tricky because they didn't put either of the lines on 0. So what we need to do is we need to subtract the two. Now we can do inside and inside or outside and outside, but either way we just need to make sure we're consistent. So let's look at this outside one. That looks like it's 70, and this outside one looks like it's about 93. So if I want to subtract those two, you're going to see I've got about 23, so that looks good. What if I were to do about the inside? Looks like that's about 110. And it's a little bit less than 90. I'm going to call it 87. So if we regroup, guess what we get? 23. So you can get the same number if you're subtracting the inside or the outside. Just make sure you do it consistently. Next, we've got this H up here. We're going to do the same thing. So this is right here. It looks like on the outside it's 95. So we'll do 95. Then on this outside, it looks like it's about 123. So let's put that up here, 123. And this might be the one, yeah, that looks like it's 28. You notice it's a little bit bigger than these other ones. Let's do the insides just to double check. That is 85. And that is about 57. So that looks like it is, yeah, it's going to be 28. So that's going to be our answer. That one is not 23, but let's just double check on this one, because this one also does not start on zeros. So the outside's pretty easy. It's right there at 75. And then that looks like a little bit above 50, 51, 52. So we'll say 52. And that's going to be my 23. If I want to do my inside, that is 105. And it looks like it's 130, almost 130. I'm going to call it 128. And there's your 23 degrees. So you can use outside or outside, inside or inside. Just be consistent. The answer on this one, number 10, is H. So let's look at our next one for today. It's another protractor, but thankfully we only have one, so it's a little bit bigger for us to look at. And all we need to do is find angle Q. Well, that seems to be pretty easy because we've been doing this. Now this is going to be, it looks like it's going to be almost an obtuse angle, because it looks like it's a little bit bigger than 90 degrees, but we'll see. We'll measure. Let's measure outside and outside. 50, and 160. So let's see, 160 minus 50. Yep, 110 degrees, which looks like it's going to be D. Definitely obtuse. Anything greater than 90 is going to be obtuse. Let's do inside, inside. 130 and 20. I could do that right in here. 130 minus 20, also 110 degrees. Now let's see what they say here. 110, because 160 minus 50 equals 110. So it looks like they did the outside outside. So that's going to be our answer. Let's look at these other ones. 70, because 50 and 20. Look what they did. They added the outside plus the inside. So you never switch between outside and inside, and you're not adding them, you're subtracting them. 150, because 130 plus 20. So they took the two insides. So take a look at this right here. You took your 130 and your 20, so at least you stayed on the inside. They added them rather than subtracting. And then 30, that just doesn't look like a 30-degree angle, because 160 minus 130. So what they did here is they did outside minus inside. You don't switch between the two. So my answer is going to be D, 110 degrees. Now our third problem for today is a little bit different. We're looking at relative mass or weight. Weight and mass are not the same thing. They're related, but they're not the exact same thing. Mass is the amount of matter inside an object. It never changes. Weight depends on gravity. So on Earth, weight stays the same, but you weigh less in space or on the moon or on Mars. So all we know here is we have a dictionary. So let's see if we can kind of draw a dictionary here. It's an open book. Most of us might not have actually used a dictionary. That's an old paper book, but they can be kind of heavy. So we're going to say this is 2.5 kg means kilograms. And then which object has a mass closest to the mass of a dictionary? So which of these four objects is going to be about 2.5 kilograms or have the same mass about as this dictionary? Definitely not a bicycle. Bicycles are extremely big and it's going to have a lot more mass. I'm thinking this pair of boots, depending if they're not super heavy boots, but that could be about the same. This refrigerator, no, not even a mini fridge. A full refrigerator is probably going to have the highest mass of any of these objects. And then I'm going to guess this. They didn't tell you what size of the bag of chips, but even if it's a big bag of chips, I think it's going to have less mass because it's basically filled with air. I'm sure you've all opened up chips. It looks like it's a full bag and only half of it actually has chips in there. So our pair of boots, and that just is kind of a guesstimate on our side. You have to kind of reason your way through it. Pair of boots, G, is going to be our answer for number 22. So that is it for today. If you would like to come and see what's going on tomorrow, you can feel free to get onto my website. It's aarondaffron.com and take a look for day 11, almost to the end of this 12-day review.